blue one is the sponge, very steady, and the orange one is the paint. So yeah, we'll just run through and show you the slides. So overall, as you can see, the thermal conductivity is much higher. We want it to be lower, to be better. So yeah. So yes. So the thermal conductivity of the paint is much higher than the sponge, but in comparison with the data sheet given, it's only 100 times more than what the data sheet given. Now you're thinking 100 times sounds like a big number. Not exactly, because in a lot of industry products, usually the difference is about 1,000 times. So actually 100 times is actually not bad, it's quite good actually. And yes. So this is the relative humidity chart. Because humidity tends to also play a part in the temperature difference in the surrounding and heat transfer, but from our findings, the humidity didn't change significantly enough to actually affect the temperature or the heat passing through. So we didn't include in our calculations because it's negligible, because it's mostly constant. As you can see, it's more or less the same. Yes. So yeah, I know I went through like a lot of graphs. So this is a simple comparison table. Average heat transferred in terms of joules, because the heat energy is transferred. The sponge is higher on average than the paint. The thermal conductivity, even though the paint was seen to be higher than the sponge, but overall, if you take into account the amount of heat transferred and everything, it's actually lower than the sponge. Yes, that's the surprising finding. Even though the graph just now, it looked like it was much higher, but overall, when you look at it, it's actually lower given that there was some negative zones and everything. And vapor permeability, this is actually another plus point of the paint. It allows water to pass out, because condensation does occur directly on the pipe itself. I don't know if you've noticed, like aircon system piping, I'll show you some pictures later. It creates air bubbles. This is caused by condensation, which will cause paint to peel off and everything. But for this paint, it breathes, so it actually expels the water out, so it preserves longer. And ease of application and setup. Sponge is relatively simple, you just slot it in the pipe, or you can cut it open and then seal it back up. Very straightforward. But the paint is very time consuming. I saw on the data sheet, the proper application is you have to do it layer by layer, let the layer dry, and then you put another layer. And each layer cannot be more than 1 mm. And yeah, it's very time consuming. So that's one downside, I would say. Critical thickness achieved, the sponge standard it came in a certain size. The paint unfortunately didn't, but that has to do more with the so-called workmanship of the painter. But overall, I would say the paint is doing a much better job than the sponge. Yes?
We still have 2 more minutes.
Okay.
Please continue.
Okay, so yeah, as mentioned, you can see the paint is like peeling off here and a lot of condensation is occurring. That is mainly because of condensation happening directly on the pipe itself, in between the paint and the pipe. And eventually when too much condensation occurs, 2 things happen. The paint will start to peel off and fall off, and it will also cause rusting on the pipe inside, which this one doesn't have the paint coating. You can tell how rusted the pipe is. Yes.
And as you can see from the picture on the left over here, there is a bucket. And this bucket is actually collecting the condensation coming from the aircon system itself. And why there is this condensation, we came to a conclusion that this was because there was a greater temperature difference in the environment compared to the inside of the system itself. And on the right hand side, there's also some condensation that you can see happening below the compressor.
Okay, so conclusion. The thickness of the paint played a crucial role since it didn't hit critical thickness. That's why in the charts it may seem like the paint is not doing a good job, but it's because of critical thickness. And previously my partner mentioned that we also had a power consumption meter. We didn't log it because this was just to see the general gist of the power consumption. And in the scenario when it was just a sponge, it was consistently very high. It was drawing a lot of power. In scenario 2, with just the paint, it was steady and much lower than scenario 1. But then in scenario 3, where it was both the paint and the sponge, it was the lowest. It consumed the least amount of power, although there were some fluctuations. So actually from that, we will actually recommend 2 things. One, you need to ensure the painter, whoever, needs to ensure that the critical thickness is hit for the paint. Or another thing would actually to use the sponge in conjunction with the paint. And yes, overall the paint did perform better than the sponge with lower thermal conductivity and less heat transferred overall, and with the added advantage of vapor permeability. Yes, so overall this FYP experience has been quite interesting for us. I actually was regretting at the start because I thought internship work experience or allowance also, but FYP has given a lot of freedom for me to actually plan the whole experiment from scratch, and I think I learned a lot more through the freedom. Yeah, I don't regret it.
So as to bring back what Darryl said, yes, I do get a lot of freedom from working on this FYP as well, as we do start from a later time compared to the intern students. And just to conclude, this hands-on experience has not only emphasized the interdisciplinary nature of real-world projects as such, but also fostered the growth in teamwork, adaptability, effective communication, and critical thinking skills, but also deepened my technical knowledge that I believe will have a lasting impact on my approach to future projects and collaborations. Thank you.
Thanks, students. Well done. So we now move on to Q&A. Maybe I will also start off with a question for you guys. So typically for direct expansion systems such as yours, I'm assuming that the refrigerant is one that's flowing inside the pipe, right? Okay. So how would you ensure that all your readings and studies are done during the full load situation where fully refrigerants are flowing through the pipes, rather than part load situations where, for example, when you turn on to 25 degrees situation and the room is already cold, there's hardly any refrigeration flowing. How do you ensure that it's consistent in the sense?
Okay, for that, at the beginning my partner mentioned our setup, we actually got an indoor place which is a controlled environment over here. So this is actually on the 5th floor of block 47, so there's already aircon running, so it will be a consistent temperature most of the time. Even if it rains outside, there's not much difference in the internal temperature, which is why we actually decided to shift it down to an open air space where it is affected by the environment. So the aircon actually has to do its work to ensure full load.
Very good. Yes. Good answer. Judges, any other questions you want to ask?
Yeah, I have a question. So based on your experience, right? I'm thinking, because the industrial demand is there, is it possible to standardize the process? So eventually, anyone comes here, can do a test, something like a package your process as a product. Possible or not?
Okay.
Actually, I would say personally that our setup is quite reliable, apart from the fact that the painting itself that was done of the pipes was not to the critical thickness level where it would be thick enough for the paint to actually be at a much higher efficiency than the sponge itself. So I think from what the experiment that we have done, I would say that personally this product really does work well, and as mentioned before in this table where we compared the effectiveness, you can tell that our overall rating of this product is that it's definitely better than the sponge, apart from the anomaly that it was based on the workmanship of the painter itself, who had done the painting on the pipes.
Thank you.
Any questions on their work? Okay, maybe I'll ask one more question. Okay. So, given that the nature of most of these ecosystems are, for example, the application of the space currently is inside under the sponge, right? So the sponge is under the ducting and it's not, it's not exposed to light. But are there any applications for this paint for not only conductive properties but radiative properties that you might want to recommend future groups to test on?
Okay, so my colleague mentioned earlier on that there are a few uses for it. I think in terms of reflective properties would be painting on building walls itself, which I think the paint has been used before. And yeah, then there will be a more direct approach for using its reflective properties.
Want to add anything? Yeah.
Oh yeah, so actually this is a already existing commercial product. So I did mention before that this can definitely be used, as he mentioned, on building surfaces. Can also be used additionally on balconies and on other systems like uh, it can even be used indoors, for example, in a setting where you want the inside, which is cooled by the air conditioning systems, and you don't want the heat to be transferred into the outside.
Okay, very good. Yeah. If no more questions, I will dismiss this group. Yeah. Okay, well done.